So a bit about me. I'm CTO Continuum Security. I spend my time doing split between security consulting and development work. And that was part of the motivation for creating the BDD-Security project, which is a security testing framework written in languages and concepts that developers understand, but for testing security features. Right, but let's start off talking about DevOps. 10-minute introduction to DevOps. So we're going to start with waterfall. And waterfall was characterized by developing software in long batch runs, right? We did a lot of upfront design, a lot of upfront development before we had something that we could test. So it took us a long time to get feedback from our tests to find out whether what we developed actually works or not. And this resulted in a high risk of project failure because things change in a project. If it takes 2 years before you have a product that you can even test, it can become quite problematic. So along came Agile, and Agile said, well, let's break this big long batch run up into smaller batches, and we'll write individual features. So we'll create a feature, we can test that feature, and we can pile them up into a release. And once we're happy with the feature set we have, we can release that set of features. And once they're released, they then move over to the ops team. Ops team get to test it into various testing environments. They have to build that environment, deploy it into the environment, and then run the tests in that environment. And finally, deploying into production, which is the first time that our users get to see these new features. So there's a bottleneck where features become a release and then make the way to the users, right? What we care about and what DevOps says is what we want to do is get those features to our users as fast as possible. We don't want to wait for a whole batch release, then send it through this laborious QA process, build those environments, configure those servers, and get the product released. What we want to do instead is extend the agile cycle. So we can deploy individual features. So we can take one feature and put it through the whole process, have it QA tested, have it acceptance tested, and finally get it deployed into the live environment. The benefit this gives us is we reduce the time that the feedback loops take to get from testing, and the time it takes our users to give us feedback on those features. So we can deploy things really quickly, and we can see that the users like it, or they don't like it, or it doesn't work, or it's broken. And in order to do this, we really have to work better together. Dev and ops and the testing team really have to be working together, and we have to get rid of this idea of dev creating a software product, handing it to ops, and then letting ops take all the responsibility for deploying it and for testing it and so on. So in order to do this, DevOps relies a lot on automation. Testing automation, acceptance tests, QA tests, automated configuration of the environments. In DevOps environments, they're building entire testing environments out of software with virtual machines and with cloud infrastructure. And automating the process of deployment. So DevOps introduced, well, continuous delivery introduced this concept of a continuous delivery pipeline, where you feed in security, or you feed in features or requirements on one side of the pipeline. Those features become code. They are tested, unit tested. They're then passed through, deployed into a testing environment. The testing environment then runs acceptance tests, QA tests, performance tests, and finally it's deployed into production in one long continuous process. And DevOps is what allows us to do that. DevOps gives us the ability to operate this continuous delivery pipeline. So if you think of ramping up from doing pure agile all the way to doing continuous deployment, the amount of DevOps you're doing naturally increases. So if you're doing just agile and continuous integration, you're still working within the development environment. Developers are building code, that code works in their environment, and that's their end product. They then give that code over to ops, and ops can deploy it into the testing environments. So at this stage, you don't need to be doing DevOps, because you're just handing over the software from development to the operations team. Once you start doing continuous delivery, you're now delivering not just code, but code and a working environment and a set of automated tests. and you're delivering that into a pre-production environment. So there's still a manual component here, some type of test you want to do manually before deploying into production. Continuous deployment goes one step further and says, well, we're going to automate the entire process, and we're going to let developers write code, have it automatically tested through all the various environments, and finally make its way into production, all in one continuous process. So if you're doing continuous delivery or continuous deployment, you have to rely on DevOps to allow you to do that. So the challenge to security is quite clear, right? Dev and Ops are saying, we understand what we have to deliver, and we understand how we need to deliver it. In fact, they understand how to deliver it so well that they've automated the whole process. That means they can allow their developers to effectively deploy into production. And some real-world examples, Amazon deploys every 11 seconds. Every 11 seconds, there's a new feature hitting production. Etsy does it 25 times a day, and even gov.uk does it 30 times a day. So the question of security is quite clear. If we have this capability, if we can deploy that fast into production, how can we do it securely? And I think the typical answer from a traditional security team is more along the lines of a continuous annoyment model rather than a continuous deployment model, right? There's no way we can do security testing every 11 seconds. That's just not possible. And there's no way security is going to allow a bit of code to hit production without undergoing adequate security testing. I think if we want to answer that question, how can we do this securely, we need to realize that security is really not that special. I mean, security is really a subset of quality control. It's a special type of quality control. So if we look at how is DevOps already implementing quality control within the process, we can extend those processes to adapt to security. And the first way they're doing it is not a technical control at all, it's a cultural control. It's holding developers responsible for the quality of their code. And the famous example of this is PagerDuty. The DevOps companies, when the production application goes down at 3 a.m. in the morning, they don't wake up the ops guy, they wake up the developer. And all of a sudden, code quality starts improving once you start holding the people responsible who write that code. And I think that's a natural extension for security. We can hold developers responsible for the security of their code. And that fits in well with the DevOps culture, that we're all working together to the same goal. There isn't an antagonistic relationship between security and dev and test. We all want to get code into production as fast as possible and as safely as possible. And then that brings me on to the next one, the idea that there is no them in the team. And this is something I think security is particularly guilty of. We're always referring to those crazy developers writing that code that really should never have been in production. We need to get out of that mindset and to think that we're all on the same team and we're all working towards the same goals. Continuous monitoring is a key part of DevOps, and I'm not going to touch it at all because I think it's an entire topic on its own. But the bit that I do want to get into is testing, and how can we extend existing testing functionality to work for security. So we typically think of tests as verification controls. That's what a test does. It verifies that something is true. But developers use tests as specification. In other words, they write the test before they write the implementation. This means that their tests act as their requirement. They don't maintain a separate document of requirements. They maintain a set of tests. So they have self-verifying requirements. And we can do the same with security. We can use automated tests as our security requirements. If we do it this way, we have tests that are code. In other words, it's treated as code, it's controlled as code, it's uploaded to the source code repository. We can control access to that code. We can roll back to a previous test if one of our tests fails. And we have the capability to automate manual tests. In other words, do the manual test once and then record it, and we can then play back that recording as an automated test. Automating the scanning process. Of course, we rely a lot on scanning to detect security issues. Scanning itself is automated, but the process around it isn't, right? We need a human to go and choose to perform a scan. We need that human to interpret the results, to remove false positives, and then to decide what to do about those issues. And we can build automation around that entire process. So let's take a look at a first attempt to doing this. We'll use a developer's tool, a JUnit testing framework. We use Selenium WebDriver to control a browser, so we can programmatically tell a browser to do things for us. And we create our specification. We want to change the session ID after login. So we write this test first, before we even write our app, so we know what we need to build. So first off, driver.get the login page of the site, go and read the session cookie, then log in, and login tells us how to log in. Find the element called username, and enter the username, find the password, enter the password, click login, and the browser is logged in. Then go and read the session ID again, and assert that the old session ID is not the same as the new session ID. So this works. We've encapsulated a security requirement as a test. But there are some problems. So firstly, the navigation logic is embedded in the test. We've got a mix here of two things. We've got our security requirement, and we've got the navigation of how to actually log in and which URLs to go to. Which means that if we wanted to apply our same test to a different app, we'd have to go and rewrite all our tests, right? The second problem is a technical issue with Selenium. It doesn't expose the HTTP API at all. The lowest level stuff we can do is read a cookie through Selenium. We can't even read the HTTP response code from Selenium. So relying on a pure Selenium solution to do this type of testing is not good enough, because we need to be able to access the HTTP layer for security tests. And the biggest problem is that it excludes non-developers. If we're in a DevOps team and we're working developers, testing, and ops all together, we all need to understand the specification. We all need to be able to understand if it's failing, why it's failing. This is written in code that only a developer is going to understand, so it's going to exclude most of our team. Solving those issues is the motivation behind the BDD-Security testing framework. So introduction to BDD, this is a BDD specification. It's written in a given, when, then format, uses JBehave, and it's written in a natural language. So everybody can understand this, right? Given the login page and the value of the session cookie is noted, when the default user logs in with credentials from this text file and the user is logged in, then the value of the session cookie issued after authentication should be different from that of the previously issued session ID. For everybody who understands what a session ID is, that makes sense. And this is executable. There's Java backing every one of these lines. Okay, so this is a BDD Port Scanner, which looks like this. Again, this is a specification. Only the required ports should be open. Given the target host, when TCP ports from 1 to 443 are scanned, we can make this 500. So we can change parameters within the natural language rules. We can use 5 threads and a timeout of 300 milliseconds. So when the open ports are selected, then only the following ports should be open, port 80 and 443. So we can run this scenario. And we have test failure. We expected a collection containing 80 and 443. Instead, we got 22 and 80. And the test failed. Our specification failed. So that's quite a rudimentary port scanner, but from a DevOps point of view and from a process point of view, it is, I think, a bit more interesting than something like Nmap and a human. Because we write this first. So the ops guy who needs to go and build the server and configure the firewall knows beforehand what he needs to configure. This is his spec. The requirement is understandable by everyone. The requirement itself is self-verifying. And we can fail the build if our requirement is not met. So imagine that continuous delivery pipeline with a new feature going in. If our tests are running in that pipeline and one of our tests fails, we can fail the build. We can block the pipeline, say, whoa, this is not going into production because our expectation is not met. So a bit more about the BDD-Security framework. It's written in Selenium, and it uses OWASP ZAP proxy to do the HTTP stuff. And using those two things, we can mimic anything that a manual penetration tester can do. So we can control the browser, we can control the proxy programmatically, so we can recreate anything that a manual web app tester would do. Tests are understandable. Yep, it fits into the dev workflow and obviously into the continuous delivery, continuous integration pipeline. The logic of the tests is independent from the navigation code. So every BDD test that is run needs its own navigation code for that app. But that code is in a separate file. So we have reusable tests. We can take the same test and run it on a number of different apps, and we just have to change the code in one place. I think it's easiest to understand it through a demonstration. Right, so the app we're going to test is this one. Very simple app, offers login. And you can see the list of tasks. You can type searches in. You can search for things. Click on your profile and so on. Okay, so very basic app. So in order to configure this for BDD-Security, you would check out the BDD-Security project. Each web app gets its own copy of the BDD-Security tests. First thing we need to configure is the config file. We need to decide which browsers we want to use to test. At the moment it supports Chrome and Firefox, and Chrome is quite a bit faster, so I'm going to use Chrome over here. It uses two browsers, one of them configured for ZAP and one of them without ZAP. So because ZAP is a bit slow for some things, if we don't need to read the HTTP layer, we don't use that browser, we use the regular browser. We configure the base URL, so this is just for convenience sake in our tests, we can just refer to that part of the URL as our web app. There's a secure URL for HTTPS. And here is a Java class file that we need to create that contains the navigation code for our app. So I'm going to create a new one here. We'll call it B-Sides. B-Sides London. Okay. Okay, so a new file, B-Sides London. We need to tell it what the session ID is. We need to tell it who the users are. So in this case, we would want at least 2 users from each role. So here we've got Alice and Bob, who are normal users, and admin, who's an administrative user, and some other configuration options. Most importantly, we need to tell it where ZAP is listening. So I've already got ZAP up and running here, listening on localhost. Okay, so the next bit of configuration is to create this file. So we extend a base class, which is web application, if we're testing web application. At the moment, the framework only tests web apps, but it will be able to support web services or anything with an HTTP communication layer. So right now, web apps, and we will implement interfaces that describe the functionality of our app. So this gives us the independence of our tests. So for example, there are built-in interfaces for iLogin for any app that offers login, for iLogout, for any app that offers logout. We'll get our IDE to complete that for us. Okay, so we need to provide these methods. We need to tell the framework how to open the login page, how to log in, how to log out, and how to determine whether we are logged in or not. And this is not that hard with Selenium. So to open the login page, we just need to access that URL, which is quite easy with Selenium. Get like that. Now we're on the login page. We need to tell it how to log in. And since how to log in is a bit complex, we can use Selenium Ide, which is a browser plugin for Firefox that will make this easier for us. So it will record our actions and save them as code. So on the login form, I'm Bob. I log in with password, and I click login. So those actions are stored by Selenium Ide in the native Selenese language, and you can then set the clipboard to whichever language you want to export to. In our case, Java JUnit 4, you can also use Ruby or whatever you're familiar with. So we can then paste this into the login function, import that, and we have login almost working. So the login function takes a generic credentials object, and we want to use a username and password. So we just need to convert that to a new user pass credentials. We don't want to log in as Bob every time. We want to log in as our credentials. Get username, get password, and click. And that's it. We've got a login function for our app. Next is quite an important one, is logged in. The framework often calls is logged in to find out whether the user is actually currently logged in or not. So we need some way to determine that. And this is something that you'll have to determine for the specific app outside of the time. So I know that if we access the URL task list, then I see the word welcome here. And that doesn't happen if I'm not logged in. So we can code that up as driver.get. Get the task list, then if get page source contains the word welcome, then return true. In all other cases, return false. And logout is the final one. This is going to be just a simple get user logout. Right. So that's the configuration that we have to do for every app that we want to test. But once that configuration is done, you can run the pre-written tests against that configuration. So let's run the authentication story, for example. So the JBehave lingo here, a story is a set of scenarios, and each scenario is a requirement. So right here, I'm going to run a story. The authentication story, run. It goes and fires up the one Chrome instance that's not using Zap, the other instance is, and runs through all the tests, and we're done. And we have a report of our authentication stories. 1 successful, 5 have failed, and 2 were excluded. So we can see the details of that. Our first scenario, passwords should be case sensitive, obviously. So when the default user logs in, then the user is logged in. When the case of the password is changed and the user logs in from a fresh page, then the user is not logged in. But in this case, the user was. Test failure. Our requirement is not met. The login form itself is not presented over HTTPS. We expected to see an HTTPS URL. Instead, we saw an HTTP URL. Failure. And so on. So you can run the authentication tests out the box with this type of configuration. You can also run the session management tests, test that logout works, invalidate the session when the user logs out, set the secure flag on the session cookie, set the HTTP only flag on the session cookie, and so on. So these are QA type of tests. These are functional security things that you'd want your QAs guys to test. But we can also wrap things like a Nessus scan. So a lot of the stories have a narrative. The narrative describes why we want this. What benefit does this story give us? So here our narrative is that in order to identify the security vulnerabilities on the host, as an operations engineer responsible for the configuration, I want to scan the host for known security vulnerabilities. And we have one scenario in there which connects to a Nessus server. It logs in with the given username and password. It uses the provided scanning policy. It scans the list of hosts here, and this is just a text file, so you can add whichever hosts you like here as part of the parameters. The scanner is run, issues are stored, and the following false positives are removed. So we can provide a text list of false positives you want to remove here. And then we set our expectation on the next line. No severity 2 or higher issues should be present. If they are, this test fails, and we can fail the build. So that's more kind of an OPSI type of test, test your environment. We also do, of course, scanning, app scanning. So since we're using OWASP-ZAP, we might as well scan using OWASP-ZAP as well. So it scans using different policies. And for each policy, it first navigates the app. A given story, again, is a JBehave thing. If we're going to keep referring to the same story in a number of different places, we can just wrap it up and say, always run this given story before you run the scenario. So always navigate the app before you scan anything. We can go and read this navigate app, which says, given a new scanning session, and the page flow described in the method navigate is run through the proxy. We don't have a method navigate in our Java file yet. We only have is logged in and logged out and so on. We exclude certain URLs that we don't want to spider. We then configure the spider. We tell the spider to go and spider the site and whatever it has seen through the navigate method. And we wait for the spider to complete. Once we've navigated the app and we've spidered it, then we start scanning it. And then we start with the SQL injection scanning policy, for example. So in order to build this or configure this, we need to create a navigate method. So we will open the login page. We will log in. And since we don't care who logs in, we'll just use the default credentials from the configuration. And now we can use Selenium Ide again to record our actions. So click on tasks, type something in, click on search, click on profile, and that's enough. So copy those, paste them, and we have the set of operations we want to perform through the proxy. So Selenium Ide can't recognize the search button, so we'll have to find that ourselves. Oops, first I have to see it. There it is. Search button has ID search. Click, and whatever we've typed in here, this is the code that's going to run through the scanner, and the scanner will recognize it, spider from it, and then scan it. And we can run that here. We'll run just the SQL injection scanning, not the whole story. So scenario run. And we should see it start up. Perform the navigation in the browser, and then start performing the scanning. It's also done the spidering already, and now the scanning.
Within your navigation, can you have it check to make sure you maintain the session and not being kicked out by request forgery offences or those kinds of things?
Yes, I'll get to that. So it's quite important that you need to make sure your navigation is working properly. And with any kind of automated test, even if your QA guys are doing automated tests, the big problem they're going to run into is test maintenance. How do you make sure your tests aren't failing all the time? The web developer goes and changes the ID of a button, now all of a sudden all your tests fail. So it's a really good idea to stick these types of verification statements in your navigation code. Am I on the page I expect to be on after I click the search button? Just to make sure that your tests aren't failing. So we have a test failure here again. Let's have a look. So the application should not contain SQL injection vulnerabilities. We expected to find no medium or higher risk, but we did find 2. And it tells you where the URL is, what the parameter is, and the CWE ID for that. And you can use these 3 variables in your false positive. If you decide these are false positives, you just add it to the story, and it'll ignore those false positives the next time the story is run. Okay, so this is an app scanning type of thing again, but we can do some more interesting things, because since we have Selenium and we have the proxy, we can even test access control between users. So to test access control, the framework needs to know who is logged in, what actions they perform, and then what sensitive data or what special data should they and only them see when they perform those actions. So in this example, if Bob is logged in and Bob clicks on profile, then only Bob should see his email address there. And we can code that up in a test. So we create an arbitrary method. We'll call it view Bob's profile. Whoops. We will firstly driver do a get. For a page, so just to make sure that we are on the front page of the app. We'll get that URL. Then we will click on the profile link, which we already know how to do, like that. And that's it. So that's our action. That's one of the variables. We need to know what action Bob performs. And now using an annotation, we tell it about who should perform that. So it's users equals Bob. Which users are permitted to perform this action? Only Bob in this case. We can provide a list of users. And let's just complete this. Sensitive data is Bob at continuoussecurity.net. Oops, I have an error here. Okay, that's better. So with this information, the framework has enough to perform access control tests. It knows who's allowed to perform this method, what the actions are in this method, and then what is the sensitive data it's meant to see there. So we can go to the authorization story, and let's run that. Run. So it's first going to go and perform that action as Bob. It's going to record those HTTP requests that are part of that view Bob's profile and store them. And then it's going to log in as every other user, switch in the session IDs, and replay those methods. So it's exactly how you would test this when you're doing a manual web app test, except the whole thing is automated. So, authorization test. It consists of the authorization story is 3 scenarios. The very first scenario sets everything up for us and just makes sure we've entered valid data. So it checks, can Bob, calling the viewBob's profile method, does he actually see this data somewhere in the HTTP responses? It then also goes and stores those HTTP responses. And the next scenario is the one that actually does the access control testing. So it uses a table that it went and created based on all the other users it knows about. So it now logs in as Alice. And the previously recorded HTTP requests for viewBob's profile are replayed using Alice's session ID. And then Alice should not see this data here. And if she does, then we have an access control flaw. So we have coded up an access control flaw here, and we can see that Alice does see that data from her session. And we can see this is a very basic access control flaw here. Any user can see any other user's profile. But we have an automated way of testing it for any number of methods and any number of users. Right. Jenkins, okay. So we have these tests. We have an automated way to run all of these tests. Next logical step is integrated into our build process. And for that, I have a pre-recorded session using Jenkins. And this would be the entire process of a developer writing code, committing it to source code, having the BDD-Security tests run as part of a Jenkins build. So our developer goes and makes changes to the web app that they're building. They decide to change the way they do queries. They change how they get access to the user's instance. And they commit their code to Git, push it up to GitHub, and that's it. So from the developer's point of view, that's it. They've just committed code. All of what happens from this point on is completely automated. Jenkins is automatically watching GitHub. If there are any changes, any new commits, it goes and pulls down the new version of the web app. So it goes and pulls the web app down and starts building it. It's compiling the web app. It's going to deploy it into a test environment. It's deploying it on Tomcat here. And it automatically kicks off a BDD-Security build after deploying the web app. Now BDD-Security starts running. It's running, in this case, in a virtual machine, just so we can see what's going on. You can run this in headless mode if you use XVB on Linux. So this is massively speeded up. It takes about 10 minutes to run through all the tests for this simple app. Going along, doing the functional tests. We can see the progress. And done. Yeah, essential Jenkins plugin is the Bruce Schneier plugin, which you must have to give your developers some idea about security. So immediately we have test results. We have 24 failures in total, but all of these are old failures. 3 of them are new failures caused by this new build that we've just committed. So we know that there are 3 new security regressions in our build. And we can click on them. We can see what the regression is, access control problem, cross-site scripting issue, and another access control issue. And because Jenkins is integrated with our source control management, with GitHub in this case, we can navigate to the code that caused this issue. So the developer can go and see, oh, hang on a minute, those were the changes I made, and those were the changes that caused my new security regressions. And the security reports, the HTML reports, are also embedded within the Jenkins UI. So while the developer is browsing Jenkins, he can go and see what the detailed issue is. Okay. So there are some limitations. There's no email functionality built in yet. So if you want to test self-registration, you're going to have to build the email functionality, go and pop an email off the server to register the user based on an email that the system has sent him. Account lockout can be an issue. So you would either have to create user accounts for the app you're testing that aren't locked out, or you'd have to be very careful about how you test those lockouts, or have a completely automated unlocking process that you can activate through the framework. At the moment, the access control tests are not anti-CSRF aware. And the access control tests are resending HTTP requests to the server. If there's a CSRF token in there, they're not going to work because they're sending the old token along. This is something I'll change quite soon. And then, as I mentioned earlier, test maintenance can be an issue. So you should do error checking as part of your tests. Security testing is a bit different to QA testing or functional testing, because in functional testing, when a test fails, you're pretty sure that something is wrong with your app. But with security testing, we want to distinguish between a test failure, that means something is wrong with our test, or a security failure, something is wrong with the thing that we're testing. So these two things require two different actions from us. One way to do this is to sprinkle your tests with error checking, like this one. So the first one about changing the session ID after authentication. Given and when. When the default user logs in with the credentials from here, so now we know that the user is meant to be logged in. But there's an additional step here, and the user is logged in. This is superfluous from a security testing point of view. That's there purely for error checking, so that if that fails, we know, hang on, we actually tried to log in and we didn't log in, and we were meant to log in. Another thing you would do then is, as I described with the navigation method, if you perform some action on a page, there's a shortcut you can do verify text present, some text. So you can sprinkle complex Selenium code with that verify text present just to make sure that you are on the right page and nothing's being missed. By the way, if you compare this to pure scanning, at least you can do this here. With a 100% pure scanner, this is often obfuscated. You have no idea whether it's actually hitting the pages you believe it's hitting. With this approach, you can see where it's going and you can ensure that it is on the page that it's meant to be on. The other thing is captures. So I ran into captures testing a production site, and I solved it by using the death by capture service. So deathbycapture.com, deathbycapture.com is a service that uses humans to solve captures. It costs €6 for 1,000 solved captures, which I think is a bargain. I don't want to know how they're doing it. It's one of those things where just no ethical questions. Right. So with our app, okay, so our app, we're going to enable reCAPTCHA on the login. If you fail login, it's going to prompt you with a captcha. So we'll trigger that manually, and now we get a captcha. So now, in order to log in, we have to solve the captcha. So the way to do this is that there's a behavior called the iCAPTCHA behavior. And we can ask it to implement these methods for us. In order to be able to solve captchas, we need to tell it three things. How to get the captcha image, how to find it on the page, how to find the response field on the page, and then which solver to use. In this case, we only support one, which is the death by capture service. So we'll first find the image on the page, which is pretty simple because reCAPTCHA uses a unique ID. reCAPTCHA challenge image is the ID of the element. We just need to return the Selenium in Selenium format, right, which web element it is. We do the same for the answer, where we're going to type the answer in so the framework knows where to put the answer in. And we set the default captcha solving service. As I said, at the moment, death by capture is the only one. This contains my username and password where I signed up with for the service. So you can use this same code for your systems. And then obviously we need to change the login function, because login now needs to check, after I filled in the username and password, is a captcha present? If it is, then solve it, and then continue sending on the login form. And since we've told it where to find the images and where to find the response field, it can do it for us. So we can run this test. Fires up the browser, logs in with Bob and his password, and now the image has been uploaded to death by captcha, and we're waiting for a response. Waiting, since it's someone typing it in, and there we go. And that was the captcha response. So it's a bit slower than doing a purely automated system, but at least you can test production apps that have captcha enabled. So basically, we've moved the way we work with our security requirements. In the old way, we would have security requirements described in Excel sheets, in PDFs, or in Word docs that we all know ends up at the bottom of someone's drawer and is never referred to again. We want our developers to use our requirements to build the app. We want our ops guys to use our requirements to build their infrastructure. But this is rarely the case. We also rely heavily on manual processes, and each of these manual processes should be basing their tests on our requirements. So this does not fit into a continuous delivery model. This method does. Instead of having static requirements defined on paper or defined in dead documents, we have requirements that are actually self-verifying. They're still in a natural language, so we can still use them as requirements to communicate with anybody else in the team, and they can verify themselves. And we can use those to wrap things like scanners, to wrap manual tests, to wrap QA tests, and to run them from continuous integration servers, and so on. Some additional resources on our GitHub page. BDD-Security uses a few components that we've developed, so if you want to use any of those components, some of those are available there. There's an SSL tester, which will test SSL on the site, like this. Support TLS 1.2. It will check that TLS 1.2 is supported. It will say that you should be patched against Heartbleed, and it will test that Heartbleed is not there. Right? So there are quite a few pre-packaged security stories, and of course you're encouraged to modify them for the app under test, and ideally you'd have this one set of stories that you could apply to a group of web apps that you're responsible for. Questions? Yes?
I'm worried about your initial assertion that testing, well, security is a subset of QC.
I know it's always a contentious point, sorry, yes.
So you mentioned Heartbleed.
Yeah.
This would not have prevented Heartbleed. It's
No.
reactive. You can look for Heartbleed because you know about it.
Yes.
But you can't do anything about types of exploit, types of vulnerability that aren't programmed into the test. So isn't that a fundamental limitation?
It is. It depends also on what type of tests you would run. So by wrapping scanners, we can do everything that a scanner can do. If you wanted to do more kind of exploratory type testing, you would want to wrap something like a fuzzer. So if you want to find Heartbleed proactively, you would have to have some kind of super intelligent fuzzer that would go and scan for that type of thing and then find those type of anomalies. Although I don't think we would have, I mean, we didn't find Heartbleed using traditional methods in any case.
No, but therefore security isn't a subset of QC.
Yes, yes. From a process point of view, we can run security tests in the same place that we run quality control tests. This can't replace a manual tester going into an app and finding new vulnerabilities. What it does provide is the facility to record those activities and put them into your test suite that you can then repeat on subsequent retests. And it costs you nothing to run a retest with this type of thing. But yeah, no, I wouldn't say it's a replacement for doing manual testing, no. Any others? Yes?
Thought about adding support for Phantom.js.
Yes, so Phantom.js is a headless browser. I have read some problems with Phantom.js that it doesn't, the JavaScript engine is a WebKit, it's WebKit, right? It's a WebKit engine, and it might not interpret some JavaScript on some sites exactly the same way that Chrome might do it. So at the moment, I'm focusing on Chrome and doing headless Chrome with XVFB under Linux. So you could at least run these tests headless. You don't have to set up a full X server to run them. But after that, I'll definitely be interested in running Phantom.js. It's also significantly faster than a real browser. So that would be a nice plus point. Yeah. Any others? Yeah.
Can this be put into anything else like cruise control? Because I've never used JS. So cruise control is something you do.
Yeah. So you can run it from, you can kick off the tests either on the command line or as a Java file. So if you can run a command line under cruise control, you can run it under BDD-Security. Good, thank you.
Any other questions? Thanks.